Hi, good morning to all. This is the third video related to efficient computation of 2n point DFT sequence. Okay, I just briefly explain the process. Okay, if we given g of n, it is a 2n point sequence. We split into two sequence, x1 of n and x2 of n. x1 of n is the even indexed sequence and x2 of n is the odd indexed sequence. And then we combine it in such a manner that x of n is equal to x1 of n plus j into x2 of n. It is an n point sequence. From this x of n, you can compute the value of x of k using n point DFT algorithm. It may be DIT FFT or DIF FFT or normal equation. Okay, you can compute the value of x of k. Then from x of k, you can compute the value of x1 of k and x2 of k using this equation. Using this equation, you can compute the value of x1 of k and x2 of k. Finally, we can find the value of g of k. G of k is a 2n point sequence using x1 of k and x2 of k using the equation. The equation is this one. Okay, using this equation, you can compute the value of g of k. Okay, we can move to a problem. Okay, here the question is that here g of n, here it is v of n is given as v of n is equal to 1 2 2 2 0 1 1 1. Find v of k using efficient computation of 2n point DFT. Okay, so the first process is here we want to compute the length of the sequence. The length is 8 because number of sequence within the number of elements within the sequence is 8. So 2n is equal to 8. That means n is equal to 4. Okay, using 4-point DFT, you want to compute the DFT of v of k, v of n, that is v of k. Okay, using 4-point DFT, you want to compute the DFT of v of n, that is v of k. Okay, so the first step is then we split v of n into even indexed and odd indexed sequence. Okay, that is x1 of n and x2 of n. Okay, so index values here, the index values are this is the 0th index and 1 and 2 and 3 4 5 6 and 7. We pick the even indexed values. So x of 0, x of 2, x of 4, x of 6. That is 1 2 0 1. Okay, that is the even index sequence. Next we write the odd index sequence, the odd values. Okay, that means x of 1, x of 3, x of 5 and x of 7. This length is 4. Okay. Next we can compute x of n, that is x1 of n plus j into x2 of n. Using this x1 of n and x2 of n, you can compute the value of x of n. Then the next step is from x of n, you can move to the value of x of k. Okay, you want to compute the value of x of k. This sequence length is 4. So using 4-point DFT algorithm, you can compute the value of x of k. You can use a DIF algorithm or a DIT algorithm, any method. Okay, you can compute x of k. That is discussed here. X of k using DIT FFT algorithm. Okay, using DIT FFT algorithm, you can compute the value of capital X of 0, X of 1, X of 2 and X of 3. Do this problem. Okay, you will get the value of x of k. X of k value is here. Then from x of k, you want to find the next step is you want to find x1 of k and x2 of k. Okay, x1 of k and x2 of k. What is the equation? X1 of k and x2 of k equation is mentioned here. This is the equation. X1 of k is equal to x of k plus x conjugate of minus k by 2. And x2 of k is equal to x of k minus x conjugate of minus k by 2j. We already find the value of x of k. From x of k, you can compute x conjugate of minus k. Okay, that is the next step. X of k is computed. This is x of k. From x of k, you can compute x conjugate of k, x conjugate of k, x conjugate of minus k. Then you can compute x1 of k using this equation. Then x2 of k. Okay. These are the values. do the problem and cross check the values. Okay, x1 of k and x2 of k. Then finally, you can compute v of k. Okay, v of k using this equation. The equation is shown here. This is the equation. Where is it? Okay, this is using this equation. Okay, x1 of k plus x2 of k into w2n raised to k. Here 2n is 8. Okay, and move on to the problem. V of k is equal to x1 of k plus x2 of k w8 raised to k. Okay, we know the value of total factor w8, and then find the values by weighting k from 0 to n minus 1, that is 0 to 3. Okay, you will get v0, v1 and v2 and v3. The remaining values is given by this equation. V of k plus n is equal to x1 of k minus x2 of k into w2n raised to k. Here also k varies from 0 to 3. You will get the remaining values v4, v5, v6 and v7. This is the final value. Okay, thank you.